So yesterday we worked on dilations, and today we're going to work on finding the scale factor of an image that's been dilated. To determine the scale factor of a shape, record one of the corresponding pairs of the coordinates. Create a ratio with the x values in the coordinate such that the prime coordinate is in the numerator and the original coordinate is in the denominator. And then third, simplify the ratio. So here are some coordinates that we're going to find the scale factor of. So for L, we have negative 12, 8 to negative 36, 24. So we take the prime and divide by the original. So we could do negative 36 divided by negative 12. Negative 36 divided by negative 12 is exactly 3. So the scale factor is 3. And we can verify this. If we do 8 times 3, we get 24. So we know we are correct. Second one, again, if we do e prime over e, we get 4 over 16. Now, I can't do 4 divided by 16. That's going to give me a fraction or a decimal, but I can simplify. 4 goes into both 4 and 16. 4 divided by 4 is 1, and 16 divided by 4 is 4. So my scale factor is 1/4. And I can verify that because if I do negative 4 times a fourth, I get 1/4, negative 1. Then t, again, t prime, we're going to do t prime over t, so that's like doing 6 over 9. Again, can't divide that. I would get a repeating decimal, but I can simplify. 3 goes into 6 and 9, giving me 2/3. So my scale factor is 2/3. And again, if I do 15 times 2/3, I do get 10, so I know I'm correct. All right, so you're going to try finding the scale factors for 4 through 5 on your own. Okay, so now we're going to find the scale factor using this image. So we only have to really look at one of the coordinates to do this. So I'm going to use the O's here. This O is at 2, 1, where this O is at 6, 3. So I need to think about what did I do to 2, 1 to get to 6, 3, since that's our prime one, or I could simply divide the prime by the original. So it looks like it's 6 divided by 2, which is 3. And 3 divided by 3 is 1, or 1 times 3 is 3. So my scale factor is 3. And I can verify this another couple ways. If we look this way, this is 1, 2, 3, 4 units long. And if the scale factor is 3, then our bigger one should be 12 units long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it definitely does have a scale factor of 3 that way. Going this way, this is 2 units long. And times 3 would give me 6. 1, 2, 3, 4, 5, 6. So another way to find the scale factor is by looking at the dimensions. All right, let's take a look at another example. So in number 7, again, we want to use one of the coordinates. So let's use M here. This M is at 0, 3. And this top N up here is at, whoa, this is really weird to look at. 1, 2, 3, 4, 5, 6, 7, 8. So at 0, 8. So 3 does not go into 8. But again, if we do prime over original, it would just be 3 divided by 8, which is as simple as it can get. So 3/8 is our scale factor. And it's just going to be 3/8 in every direction because, again, this is 3. This would be 3, negative 3, 0. And this would be negative 8, 0. Okay, so it's not going to change it. And again, if I look here, this is 3, but then going all the way up, 4, 5, 6, 7, 8. The whole thing would be 8. So that makes our scale factor just 3/8. Okay, so you're going to try 8 and 9 on your own, finding the scale factors. Check in with me so I can be sure you've got it before moving on to today's exit ticket.